Evening, everyone. So, hope you're all doing good. Um, I guess we can get started. So, I've been traveling this week, so I thought people. So yeah, hope you've had a good week, and as usual, I'll give you the introduction for those people who are new here, just to get them started. So this is the third week of our presentation, right? This is live sessions, and as we move on, let's move into some practical aspects of cybersecurity today. Right? Okay, we can wait for a few minutes and then. Hi. Hello. Yeah. Okay. Hi. Good evening, everyone. Yeah. So we'll keep today's session purely as a supplement to what is being taught in the main line of the NPTEL course. So I believe there were a lot of requests in the previous two classes regarding what practical aspects of cybersecurity will you be teaching. So let's begin with let's start and scratch the surface of the practical aspects of cybersecurity or other penetration testing, right? So just to give you a flavor of what it is that you might expect with this line of work. Okay. So before we go into that, let us have a brief overview of what we did in the last 2 weeks. The first week was just the basic introduction to what cybersecurity is, basic definitions, basic terms, and then in the second week, I believe we looked into the CIA triad. And hello, now, hello. It should be audible now, right? Should be audible now. Okay, good. It's audible. So in the second week, you learned about the CIA triad, right? Confidentiality, integrity, and availability, right? Yeah, exactly. Um, and now, as a part of week 3, you've been introduced to organizational security. So, how do you minimize risk when it comes to looking at cybersecurity in the context of an organization? How do you minimize the risk? So, it is from an administrative point of view. The week number 3. I don't know if you've seen the videos. While the videos are self-explanatory, and you can always go back to them and rewatch them, and you can always answer the questions based on the videos. I was under the impression that maybe we can supplement it with some practical aspects of cybersecurity today. Um, so a local setup of how you can start with penetration testing. And hello, hello. I wonder why. Hello, should be audible. Is it not audible now? Should be audible. I think I can hear myself. So yeah, where was I? Yeah, we were talking about organizational security, right? We're talking. I mean, this week spoke about organizational security, how do you minimize risk, and various theoretical definitions of how cybersecurity is looked at and modeled from an administrative perspective. While you can always go back to the videos, you can rewatch them, and you can answer questions based on those. Of course, I'll give you the answers to all the questions towards the end. So I was thinking maybe we could deviate a little bit from that and give you an idea of some practical hands-on introduction to how do you learn penetration testing, how do you put it into action, right? While the course looks at the other aspects of it. So because of the requests from the previous weeks, I was thinking maybe we could introduce a little bit of this today, and if in case it doesn't work out, we can always go back to the theoretical aspects of cybersecurity. All right. So before we go into it, I think we'll have to rehash certain basics because I think in the forums as well, people have asked what is phishing. So what is phishing? So I think phishing is a very uh, it seems to be intriguing a lot of people there. Once again, let's try to rehash everything, and then towards the end of today, I'll be showing you a local setup of a virtual machine which contains a server, and this server is vulnerable to many exploits. Okay, it's got a lot of exploits, and we will try and exploit one of these vulnerabilities and try to gain access to the server unlawfully, right? While all this is being done in a playground environment or a sandbox environment, it should not be um, replicated, I would say, in on any other systems without permission of the rightful person. But nevertheless, I'll just show you. And by the way, whatever I'm going to show you is freely available on the internet. You can always go and search for it, and you'll be able to find a lot of sources regarding this. This is just for those people who just can who want to take a look and see okay how things happen, right? Okay, let's wait for a few minutes and then we can begin, I guess. Yeah, while we're waiting, I do have to tell you that these are a part of a weekly live interaction sessions. So this is the third such interaction session. So every week there are 3 PMRF scholars. So PMRF means Prime Minister's Research Fellows. So we are all PhD students, but we have been awarded by this PMRF award, which mandates us to teach or share our knowledge with with prospective students. All right. So um, yeah, so there are 3 sessions of this sort. One happens on Friday evenings, which is right now. The other one on Saturday afternoons, and the other one on Sunday evenings. Right. So I did observe yesterday that somebody was asking, is the session going to happen or not? So I believe you're supposed to see the mails, the emails. The email clearly states that the date is 9th, right? 9th of August is when the session is going to happen, not the 8th. So I think people were confused yesterday, and some people were asking, is the session going to start or not? So the answer was no. And yeah, so you get a reminder mail one day before the actual date of the session, right? So if the session is today, you get the reminder mail one day before. Okay. And yeah, once again, there were some questions regarding missing these sessions. While these sessions are not strictly necessary for you to pass this course with flying colors, you can always try and find what it is that adds value to your knowledge from these sessions. And in case you miss them, absolutely no problem. You can always go and look at the sheet which they've shared with you, I guess. I think everybody should have access to that sheet where we post the videos of the recordings of the sessions on YouTube. You can always go. You can watch it in 2 times speed, 3 times speed, right? Because these sessions are mostly catered to the to people who are. I mean, at least in my mind, I want to cater these sessions to those students who don't have a thorough introduction to computer science, or who are basic beginners in this domain, right? So it's catered towards them. So for those who are a bit advanced, you can always drop off. You can look at, you can just browse through it on YouTube, and then you can come back right later. Okay. Um, so as it is, let's do the usual ritual. So this is a part of the NPTEL Cybersecurity and Privacy course. And my name is Harish. I'm a PhD PMRF scholar in the Department of Computer Science and Engineering, IIT Hyderabad. So I usually go through the set of questions that are earmarked for that particular day. And by the way, what are the objective of these sessions? The primary objective of these sessions is for us to discuss the previous questions, right? And so the previous questions will be discussed and add extra value if in case there's a chance and opportunity to these to the course, right? So these are the previous questions which I'll just read through. I won't tell the answers. I'll probably be giving you the answers towards the end of it, because today we're going to look at something slightly different, uh, certain practical aspects of uh, penetration testing. Okay, so which of the following terms best describe the specification of a model to be followed during the design, selection, initial and ongoing implementation of all subsequent security controls? So is it a blueprint? Is it an NIST handbook? Is it security plan, an information security framework? So all of this is coming from an administrative perspective. There is not a lot to explain here. So is it true or false? Oh yeah, Pratiksha seems to have the answer. C. Okay. True or false? SP 818 Guide for Developing Security Plans is considered the foundation of a comprehensive security blueprint and framework. So again, this is coming directly from what people have already set up. So this SP 818 was a framework that was developed at uh, at organizational security, and is the foundation for a security blueprint for any organization. The question is whether it's true or false. So one of the foundations of security architectures is the requirement to implement security in layers. So what is this layered approach referred to as? So when it comes to security in layers, right? Okay, 1 second. So I'm not feeling well today. My voice might be a bit low, and I'm traveling as well. So you can always bear with me on that aspect. So security in layers. So when it comes to layers, right? Is it very? This must be very synonymous to some layers in networking. I do not know how many of you have gone through computer networks, but computer networks traditionally has many layers, right? So these layers are generally um, instrumented for for uh, for a more defined way of looking at a huge uh, a huge what should I use? A huge mechanism, let's say. Okay, so let me just break it down. You have computer networks, right? Computer networks is what defines how one computer, one system on the node communicates with the other system, right? So all that you do is you just go and type google.com and you're able to get information out. But underneath that, you have packets that traverse all of these layers. So what are these layers? Application layer, um, transport layer, etc. So there are 7 or 5, let's say 5 layers. So why do we look at it like this? Because it's easier. The abstraction is easy. Each layer has its own function, and one modification of one layer generally does not have huge repercussions on the other layer. In the sense, they're insulated from each other. Right. So this is how networks are looked at. So in the same way, security is also looked at in layers. So what does this layered approach refer to as? Once again, directly from the videos. Yep. So control objectives for information and related technologies is a framework created by Dash for IT and management and Dash. So once again, these are all directly from the theory. So nothing much to explain here as far as I'm concerned. So I'll be giving you the answers towards the end of the session. Okay. So these are the 3 approaches to cybersecurity and management. So of course, this is something from the very first video. What are the 3 approaches to managing cybersecurity? It's a very direct question.
Sir,
So
please repeat question 4.
okay, right. I've not given the answer to this, by the way. I'm sorry, my voice is low because I'm not feeling well, and I think something wrong with my mic. Now I can't speak out loud as well. I'm in an environment where I can't speak out loud, so you'll have to manage. Yeah. So what do you want in question number 4? You want me to read it out, or okay? So control objectives for information and related technologies is a framework created by which organization for IT management, and whom? Basically, is it the chief officer, or is it the IT governance security officer, or is it the information officer? So again, this is just directly from theory. Nothing much to explain here. You just need to learn certain related terms and keep it in mind, right? That's it. You had any specific questions regarding this? I believe not. Right, and this is directly I think from the first video. Yeah, but let's answer it towards the end. I mean, I'll just be giving you all the answers. That's all. Okay, and so you have these ISO standards, and what the ISO 2012 standard, it involves guidelines. Week 3. Uh, this is week 3, right? Or am I wrong? Let me see.
Absolutely.
Okay. Um, so basically, as computer networks evolved, the more people started getting on the internet, the more we needed guidelines for safe and secure networking, right? And these guidelines also evolve. So it's like this: you have technology that is going up, correct? Tech, and the more technology rises, the more there is chances of misuse as well, right? So because you can do A, B, and C with technology. Let's say technology in the sense you can code a thing in multiple ways, right? You can code a particular program in multiple ways. But what is the right way to code? What is the right way to code? So these standards, or rather these guidelines, you could say, so all guidelines are built after careful examination of what is considered best practice in order to avoid such kind of attacks, right? Such kind of security breaches, right? So this is coming from an administrative perspective, where they basically tell you that please do not do the same thing in a particular way. So for example, if you want to reach destination A, you can take this path or you can take this path. So what these guidelines do is they say do not take this path, because if you take this path, it is vulnerable to certain attacks or certain security vulnerabilities. Right. So these guidelines, they also evolve. So as networks evolved, as the internet evolved, guidelines also evolved. So they start adding things. For example, in IT law was never a thing for a long time, and then IT law came up because crime started happening in the cyberspace. So these things, they evolve, and as they evolve, we start getting guidelines. So essentially, the way you have to look at this week's syllabus, or what was being taught, is from this perspective of, okay, as human beings, we are evolving in terms of technology, and then how do we ensure that this technology is not exploited, it is less exploitable? How do we ensure that? So for that, you build guidelines or frameworks, and then you force organizations. Basically, you build these guidelines and frameworks, and then you force organizations to follow these guidelines, and say that if you follow these guidelines, your attack surface is minimized. And what I mean by attack surface is you're open to less number of attacks if you follow these guidelines. Right? Um, I'll just give you an example, very crude and rudimentary example. I do not know if you have heard of buffer overflow attacks. Buffer overflow. Okay. Oh, okay, you heard it yesterday. Hmm. Good. Oh, it's all on. Okay. So you would have heard of buffer overflow attacks. Now I'm talking about buffer overflow attacks in the context of what could go wrong if you don't follow best practices, right? If you don't follow some guidelines, what could go wrong? So, the computer memory is divided into multiple chunks. So there is this code block, and there are multiple other blocks. So in C or C++, you tend to um, allocate some memory, right? Right. So this allocated memory is functioning in a particular block. So see, I'm explaining this in a very, very generic way. I'm not going into the details of it. Once again, this course is not for the details of things. It is just an overview of all these concepts. So I'll be very, very generic. Okay. So you say you're dynamically mallocking, MALLOC. Malloc is where you um, allocate memory dynamically, right? And all these go into the heap or the stack or whatever it is, right? I don't want to put all those things. So they all have their own memory space. Now, the question is, if the input to one of these variables, right? So let's say we are taking in an input A, which is an int variable or something. But if the attacker is going to give more than what is required for this input, hmm, he's going to give uh, what do you call a huge input to this. So what happens is the input tends to overflow from this memory space to another memory space. So some of these memory spaces are not that dangerous. Some of these memory spaces are dangerous in the sense whatever is there in this memory space is the execution. Is in the execution. You can say whatever is there, that code is executed. So if an attacker can find a way to add more to basically inject a code in the space of this variable, and this variable basically overflows into this execution block, let's say. Okay, it overflows. Then what happens? The code that the attacker just injected gets executed by by that program. So I'm not sure how many of you followed along. So in a sense, you you given more than what's required, and then you ensure that the buffer is overflowed, and whatever you have given beyond that is legitimate code that gets executed by the program. So there are techniques to do this. There are multiple nuances here, but the general idea is this, right? So why did this happen? This happened because they did not do bounce checking, right? So one of these guidelines would basically say, do not let the attacker input any arbitrary value. Check the size of the input, and do not proceed if it is anything other than what is expected. That stops this kind of attacks. So you can always code it without these checking or with the checking. So these guidelines basically say you need to do these kind of checks to avoid such kind of attacks. Okay, and buffer overflow has been used a lot, especially in the server environments. Attackers have found ways to leak. Sorry. Attackers have found way to leak the I mean not leak, I would say to overflow any variable or any input to a program. So he's asking how is the code input. So basically you see any program, right? Any program that is running on user input. The user input could be what you enter on the keyboard, or it could be what you send as a packet on the network. So this program could be running on a server as well. That is the input basically, and this input you enter something that's not expected by the computer, by the server or the program. Okay, so I'll just be clear again. So this program, right? This program could be running here, and this is basically a computer. Okay, it's running here. Could be running here as well, and the attacker could be on the computer and trying to destroy this program. Okay, or the program could also be running on a server. Correct. This program is running on the server. P is the program, and you are over here. Okay. Now you know that you're able to communicate with this program. It's in the server. How do you communicate with the server? The server runs certain programs. Have you heard of Apache? So Apache is one such program that serves web pages to the people who are requesting it. So when you request web pages, how do you request web pages? You send packets. So how do you send packets? You don't. Your browser does that for you. You just type google.com. What your browser does is it beautifully packages it in the form of packets, and it is sent. Now, instead of letting the browser create these packets, you can also create these packets. You can, instead of making the browser do it, you can also write a program, and you can also create your own packet, and you can send it. But this packet is going to contain malicious code. code that is designed to break this program or induce a buffer overflow in that. So that's basically how code is input. You can look at it from a local perspective, where it's happening on the local machine, or it could also happen over the network. Correct? So this is how you're supposed to look at it. That's clear, Ajinkya? Yeah, you could say, but what we exploit here is not um uh okay. So non-sanitized input form can be spoken about. We can speak about that in terms of either, I think, SQL injection, right, or cross-site scripting. So in both of these cases, we tend to sanitize input so that the attacker cannot execute his own code in terms of the query language. But a funny story is what is being sent there is expected uh, behavior of the program. But what happens in buffer overflow is you tend to break the code. It's functioning in ways it's not even supposed to. You're running over their memory and you're wreaking havoc in their memories. So that's a fundamental difference here. But yes, sanitizing input um, is a good way to look at it in the network. In the network perspective, yes, what you're saying is right, sanitizing the input. But in the local perspective, where you can break certain programs, not so much. You can't just say sanitizing the input. It's about the way you um, design your program itself. Yeah, you can definitely take a look at it. There are good videos on buffer overflow. It's called computer file. Okay, note this down. Computer file. PHILE. Okay, computer file. Okay. So this is a YouTube video. This is it's this YouTube channel, and it's run by professors from, I think, Europe, and they talk about such interesting concepts. You have heartbleed attacks, how these things happen. You have slow loris attacks, DDoS attacks. You can just watch it to gain perspective of how things happen, and they can explain it to you in ways better than anybody else can, or I can explain, right? So you can please go ahead and take a look at the buffer overflow video. Maybe I'll even post the link to you. Yeah, hold on. But again, see, I'm digressing from what the actual objective of the course is, so do not digress yourselves. This is just to create interest in you regarding web security. Right? Give me a moment. Yeah, I think that should be good enough. That's a heavy video in itself, so you can take a look. Yeah, so why did I talk about all of this? It is to tell you how and why these guidelines evolve over time, right? Why do people come up with all these rules and mumbo jumbos that people have to follow? It is to improve cybersecurity in a broad way, you can say. Okay. So this is once again, oh, okay, to change can change it. This is directly definitions, which I'll just give you the answers for. Okay. So again, these are all ISO standards, and what do these standards talk about? Oh yeah, they're industry best practices. Um, yeah, so each of these they talk about one aspect of industry standards. You can say as Ritu was just saying. So what is the correct answer here? And again, these are all completely definition based answers. Okay, that being said, let's move over to the supplement um, topic for today. And mind you, I am repeating it again. What I'm going to show you from this point on is not an actual part of your is not an actual part of your current course. It is just to give you exposure, right? No one's going to ask you any questions from what I'm going to speak about in the next 20-30 minutes, all right? So you don't have to post questions on the forum regarding that because it's not a part of the course, but I think you can. I'll answer you there as well. It's fine. It's okay. I guess the thumb rule to studying for the exam is to be thorough with the videos that have been taught in the class. I mean, in the class, I mean the main class, your NPTEL videos, right? The three the videos, sorry, the weekly videos that are unlocked. Those are the best way for you to prepare for the exam. There is nothing else. Just be sure about it, and if you have any extra time, you can go beyond it. But that should be your, your prime focus. The videos that are spoken about in the weekly sessions. Oh, sorry, in the main session. Okay. I hope you attended the interaction session with the professor. I think on 5th August. You could have asked all your doubts there as well. Okay. Okay. Just give me a moment. So in the last session, we were going through these slides. I believe we didn't finish it. So let's finish it and then let's move on to the hands-on explanation of how um, penetration testing works. Okay. Again, this will only be a rehash of what we've done last week. So what is the security problem? Security arises because of, let's say, the problem arises because of a lot of buggy software, and you also have social engineering. Why did I not speak about social engineering formally? So social engineering is when you use information that you know about someone and thereby making them believe in you and give you details or access to things that you're not supposed to get access to, like their passwords, their bank details, etc., etc. So again, internet infrastructures are regularly targeted by large scale attacks. So these are DDoS attacks, right? So how does this social engineering scenario work? So how does this phishing work, correct? So we had questions on phishing, we had questions on spear phishing last time. Okay, so the attacker performs something called reconnaissance. This word might be new to some people. So what does reconnaissance mean is he targets someone and he tries to gather as many or as much information as possible regarding that person. So you want to target, okay, let's say, okay, let's say you want to target someone who's working in a defense organization. Okay, so then you start looking into his life, you start looking into what he likes, what he does not like, and what he will respond to, what he won't respond to, right? So someone who's working in the defense area would be interested in words like security or missiles or army or whatever, right? So then you use this information. How did you get this information? You gather this information through reconnaissance. You gather it and then you craft a message or an email which could either contain a PDF file or it could not contain a PDF file as well. So you basically craft a message and you send that message to the victim who you've been looking at, correct? And there is a high likelihood or there's a high chance that the victim could will open that message because you have made sure that you have used all the information that you've gathered regarding that person, and you have uh, made it very attractive for that person to click on that link or to open that email, correct? So this is how social engineering is used to ensure or make it very likely that the person will click on that link. And then once he clicks on that link or opens that file that has been sent, uh, sorry, what is that? Okay, file that has been sent, he's either infected with malware, or in the case of phishing, what happens is you tend to give a link of a page which contains enter your username and password, something like this. Okay, that's phishing basically. So this is a slightly different scenario, but the root cause of all this or the initial step is social engineering. So social engineering happens before a phishing attack. Okay, there is two. Something at this point I missed. So phishing again can be spear phishing or normal phishing. So spear phishing is targeted phishing. What I was telling here was targeted phishing. So normal phishing is when you target a group of people and see how it works. So you don't exactly use specific information. You say things like you have this claim, click here, blah blah blah, something like that. So that's how normal phishing works, right? So it's spear phishing and normal phishing, they're very similar, except the context in which they are applied to. So yeah, so either it could lead to another page or it could install a malware which will gather such data. And when it comes to such malwares, right, it doesn't have to be very sophisticated malware or anything. It can be a simple Python program. So we call such PDFs which contain these malicious code that you want to execute on somebody else's machine, right? We call them as payload. Payload. So these are all terms that you can use in the future or in your exams or I don't know wherever. That is a payload. So what can be the payload here? The payload can be a simple form, or the payload can be a PDF file, or the payload can be a simple Python program also. So the simple Python program can act like a keylogger. I don't know if you've heard of this word keylogger, but at some point of time it was the rage because keyloggers are those programs which basically record everything you type on your keyboard. Okay, if you're recording everything that is being typed on your keyboard, then that means the attacker gains access to whatever you're doing on your system. So it's basically a program that keeps running on the background, which keeps recording everything that you type. So you can create a simple keylogger using Python as well. The question is, how do you make your victim execute it on their system? And that is where social engineering comes. So the payload contains either of these three things, and sorry, it contains either of these three. I would say these three things. Yeah, let's talk about, and it could be as simple as a form, or it could be as complex as a malware. It could be something more simpler like a keylogger. So what this keylogger does, it logs and then it sends the data to a remote location, which is remote location is basically you, sends it back to you, the attacker. Okay. So this is basically social engineering, what is called searching for loans.
So it's like initially one person is looking for loan, getting loans, but he stopped that search, and later on he start getting those text messages that easy loan without interest or less interest, and these are not the messages which has the link from the like banking sites in AR. These are not coming from the authorized bank. They are something like uh, uh, kind of very having different kind of sources, yeah, links. Click on this link and get a easy loan. Even if we are watching these days, we have a digital message, oh, pakda wala types ki easy loan, want to have the easy loan service. So are these also phishing kind of scenarios which are not driven by the social engineering?
So I think you are talking about it in the context of advertisements. Okay, let me explain that. So what you're saying is, if
Advertisement is
some
like I have given just it as an awareness which RBI or some these institutes are doing, but these are things which is happening कि एक लिंक आया था, हमने क्लिक किया और हमारे अकाउंट से पैसे चले गए. तो वो text message में आते हैं, they are coming in the text message, and these links are also given in the text message only, that you click on this link and then you it is a easy way of getting the loan. And people get into the trap ki, okay, we don't have to do the documentation, we don't have to provide any of the these kind
correct,
of legal formalities.
correct, correct. Uh, so essentially, these are scams. I mean, I would you can say it is slightly phishing, but essentially you are enrolling someone into something that is a scam, right? That's what's happening in the end. You do get the loan, right? Or do you don't get the loan if you click it. You won't get the loan. Only your personal information will be taken. So but yes, yeah, so that is phishing. But I thought your original question was, once someone starts looking at loan websites or loan related issues, he starts getting messages of the same sort. That was your original question, right? Or was it
Right,
not?
right, 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 right.
Correct. See, that has to do a lot with ad revenues and you know, SEOs. Oh, sorry, not SEOs. So basically, what happens is you have cookies in the browser. So you have mechanisms which basically track the way a user behaves. So if you search for, let's say, um, toy cars on Flipkart or Amazon or even on a search engine, so you have multiple trackers, multiple third-party cookies that keep track of what it is that you're searching. And these third parties, they sell this data to potential websites who want to do targeted advertisements. So what that happens, so the term for that is targeted advertisements. So it's not just normal advertisement. Okay, on TV you get advertisements for soaps, oils, and all that stuff. That is not really highly targeted. That's for the mass media. But then if you know a person is looking for this particular bag or shoe or whatever, then you just flood that person with so many bags and shoes, so that increases the likelihood of them clicking on those. So this is happening in the form of targeted advertisements. But when it comes to these loans, on all these things, also this could work. So imagine if all these cookies that are being collected, or all this personal information that has been collected, is sold to a malicious user or a malicious person. So he'll know who are all looking for loans. Then he'll send these messages only to those people who are looking for loans. As simple as that. So the same targeted advertisement can be used for malicious purposes as well. So I think that's what you asked in the beginning, right? Yeah, Brave browser.
Thank
Yeah,
you.
you're right. You have all these things. You have DuckDuckGo as well. DuckDuckGo is a competitor, contemporary of Google.com. It's a good search engine. It makes sure that your data is not tracked or used for any of their ML models, or they would try to profile you based on what you search, right? So DuckDuckGo. What's the code of it? Okay, keylogger. Right. So you've understood what a payload is, right? Hiranma, you've understood what a payload is. The payload is going, yeah, okay, good. So a payload could be either a form where you will make the user enter their personal details, which is later going to come to you, or it could also be a malware, which is a slightly more complex uh, software, which basically goes into parts of a system where you're storing your credentials and everything, and it just sends it back to the person, back to the attacker, that is. Or it could also be a keylogger. So what is a keylogger? Let me just clear this. Okay, so called a keylogger. Um, what is a key? It's your keyboard key. What is a logger? Log. Logs. Logs means keeping a record. So it's a logging of all the keystrokes. Right? So what this program does is, this keylogger, it is running in the background of a computer, of a system. Okay, this is your laptop, let's say. Keylogger is running. Now you are opening up a browser and then you're typing your username. Okay, let's say Kiran1. So what keylogger does, it keeps record of whatever keystroke it is that you're pressing. You press K, it is K is recorded here. Because if it is H, it's H. So essentially, whatever keys you're pressing, it's recorded by the software, by this keylogger, right? And this is periodically sent to the attacker from time to time. Okay, so this keylogger, you have many commercial softwares as well. Commercial, which means already it has been created and it's being sold. And generally, these software, they are they are basically um, available, I think, for some amount of money, and you can set this up on somebody's system as well. Okay, or you could create your own keylogger using Python. As in the one of the beginning classes, I was saying that Python is a very rapid prototyping language in the sense that you can literally do things very fast with Python. Okay, it's yeah, you can just find tutorials online as to how to make keyloggers, right? So it's not a big deal. The question is, how do you make the other person click on it, correct? And that's where social engineering comes in. Essentially, keylogger is logging your keys and sending it to yourself. That's all. If you have already existing software for that, or you can create your own software for that. Okay. Right. While in the last class we just grazed over these attacks, right? I think we can talk a little bit more in detail about this. So attacks on the internet infrastructure. So what is this internet infrastructure? Now, while the class that the course that you're taking is talking about organizational security, I'm highly deviating from that. So do not consider this as the main syllabus for your exams or anything. This is just to pique your interest in security, nothing else. Okay, keep that in mind. So you have the internet, right? So internet is nothing but a collection of nodes. Agreed? It's like this, and one of these nodes is you. Okay? One of these nodes is you, and one of these nodes is the server. Correct. So, and this infrastructure in the middle is called the internet. You can say internet infrastructure. It's a lot more nuanced than this. It's got a backbone network. It's got many subsidiary networks. It's got the DNS system. It's got so many things. But this is not a networks class, so we won't be going into details of that. So I'm just abstracting everything as the internet infrastructure. So let's say this server, right? This is where GitHub is hosted. GitHub was a is so GitHub is a famous collaborative tool. So all these are, of course, hosted. In the end, they're hosted in bare metal servers. That's all. You just abstract it like that. You can understand things a bit more easier. So what happened to GitHub was it was targeted by a 1.35 Tbps distributed denial of service attack. So this is 1.35 Tbps, terabits per second. Correct? So many packets were being sent to GitHub like this. So these are originating from multiple places. Correct? So these packets were going and it all went to the same destination. Whereby GitHub was not able to handle all this traffic and it died down. I mean, and then it froze. It hanged, you can say. It hanged. So usually the traffic expected there is 0.1 Tbps, but the traffic rose to 1.35 Tbps. So what attackers did? What did the attacker do here? So the attacker perpetrated something called a DOS, distributed denial of service attack. So you've heard of denial of service. So something is available, you make it unavailable. So in the CIA, you target the availability of the system. Correct? And that's what DOS is. Distributed denial of service is one step ahead where you use multiple sources to perpetrate denial of service. Correct? So this is an attacker node, this is an attacker node, this is an attacker node, okay? And this is an attacker node, let's say. All these attacker nodes are under the command of the attacker. Okay? So he has control over all these nodes. And what he does, he just says at one point, send as many packets as possible to GitHub, all of his nodes under his control. Correct? And what happens there? At the same time, if you're sending so much of traffic, the the target or the server tends to fail and it tends to not be able to handle all this traffic. Correct? So when I said an attacker is having all these nodes, correct? He has a collection of nodes n1, n2, n3, let's say n million, let's say n million. How does he get all these nodes? Have you wondered? How does he get all these nodes? Can anybody answer? How does an attacker collect such nodes? Good, yeah, botnets. But how does he attain botnets? Again, well, it's of course botnets. He's right. So this collection of nodes is called botnets. But how does the attacker get botnets? Yes. So it is by exploiting insecure systems or unsecure systems. So now you see where we're connecting. So we have vulnerabilities. How do we exploit a system? Through vulnerabilities. So an attacker tends to target those systems that are vulnerable to. Yeah, you're right. Even Wi-Fi routers might be a part of a botnet. You're right. And yeah, and once again, these vulnerabilities, right? Yeah, you're right. You're right. If firmware is not updated, you have certain open vulnerabilities which are not patched, and people can exploit it. So what happened was there was this famous botnet called Mirai botnet. So this was a collection of IoT devices. So what are IoT devices? These are limited functioning devices which communicate to the internet, but they are not as full-fledged as a computer where you can do whatever you want. They communicate to the internet or to their servers at a limited capacity. So a video camera is an IoT device. Your Amazon Echo is an IoT device. Your door sensors could be IoT devices. Your smart bulb is an IoT device because you're able to communicate with it or control it from remote distances, right? From long distances. So what was done was the attacker found vulnerabilities in these IoT devices, and especially I think cameras of a particular sort, and he created a botnet of multiple such cameras. So he had it all under his control where at a click of his button, he could send traffic to a single destination. That's the key. Multiple sources, single destination. And when that happens, a distributed denial of service attack happens. Okay. These are the kind of things that could happen if vulnerabilities exist. Correct? Again, another DDoS attack in 2020, but this time the scale increases to 2.3 Tbps. In 2021, Microsoft was targeted by a 2.4 Tbps DDoS attack. Right, but of course, they could not um, succeed, but still, it is quite high nevertheless. Let's just quickly go through these definitions. Well, I think we already did it. Um, so security. What is the meaning of security? It is a state of being free from danger or threat, right? And what does security entail? It entails the safety of a state or organization against criminal activity. It depicts the procedures that are followed or measures to be taken to ensure the safety of the state or an organization. This is very self-explanatory, and it's in a very generic sense. It's the state of feeling safe and free from fear or anxiety, so that we feel secure, right? That's security. The same security, when you add cyber in front of it, it becomes a state of being protected against criminal or unauthorized use of electronic data, or the measures taken to achieve this. Right? So, what are the key layers? I wouldn't say layers. Okay, let's say elements of cybersecurity. You have application security, you have information security, you have network security, and then you have disaster recovery. But let's not look too much into this. You have operational security, and you have end user education, which is basically a mitigatory strategy to stop secure to secure things. Correct. So the key distinctions between the first three, right? So application security. So this application security talks about those softwares which are wrote and that are built for mass consumption, and how do you make sure these softwares are not exploited. Now, for example, in this, I think all of you would be familiar, or at least some of you would be familiar about cracked games, or these are highly illegal things. I don't endorse any of this, but you can say cracked, cracked games, where you have an official game, and then you also have an unofficial version where someone has ensured that you can play the game for free. How? That is by modifying the exe file, the executable file, right? So by doing that, you ensure that the application becomes free, which was previously pay to use. Okay. So application security tries to stop such kind of malicious pirating activity, as well as exploitation of the application for for for, for other activities like DDoS attacks. Information security is a slightly nuanced uh, concept where you have Alice and you have Bob. How do you keep the security that is in transit between A and B safe from an attacker called Trudy? Correct? Um, Generally, that's what it talks about. And network security is in the context of the internet and and computer networks. Correct? I think those are three major aspects, and these operational security. This is what your course talks about here: operational security and organizational security. Right. Um, Again, this is Alice, Bob, and Trudy. Right. Alice and Bob wants to communicate securely. Trudy may intercept, delete, add, or modify their messages. Essentially, Trudy can either passively listen. It can either be passive or it can also be active. What is active and passive? Sorry, active. So being passive would mean that you are just observing what is going on from left to right here. Okay? You're just making conclusions from it. But active means you're inserting your own messages. You're modifying the messages that are in transit. So that's being an active intruder. Okay. So passive and active, both are possible for someone like Trudy. And who's Trudy? It's a man in the middle. So we did see this. I think let's not take it again. So what all can Trudy do? What all can the man in the middle do? All So you can eavesdrop, you can insert messages into the connection, you can impersonate, you can hijack the conversation by inserting your own messages, and you can completely stop messages from going from Alice to Bob. This is also possible, and that is a denial of service. And then comes the security trinity, which is the CIA. We saw this in the last class: confidentiality, integrity, and availability. And then we saw the multiple discussions that went along with this. So I don't think we need to go through this again, or maybe we can. I don't know. Um, Confidentiality, integrity, and availability. I think we did see this in the last class, right? So one thing to look at is what is a vulnerability, right? It is basically a flaw in a software or a firmware or a hardware which is resulting from a weakness that can be exploited, causing a negative impact to the CIA triad. So a vulnerability impacts the CIA triad, correct? That's how the CIA triad is involved here. And again, just in case something is vulnerable does not mean it results in an attack. Uh, there could be nobody who's exploiting it also, but that vulnerability might remain. Okay, right? And exposure. So what is exposure? It's another term. An error in code or a configuration issue that gives an attacker indirect access to a system or network for information gathering or hiding their activities. So exposure is more of a passive exploit, you can say. It is just that the software or the person who has coded the software is giving more access than what is required, more visibility than what is required. So you are exposing things that are not required to be exposed. For example, when you're connecting to google.com, Google doesn't tell you which server and which port you're connecting to. But what if someone codes like that saying, okay, let me tell the users which server, which location it is, and everything. So that is basically extra exposure that is not required. So that's what exposure is. So threat, attack, and passive attack, right? So let's go through these things first. So threat is an adversary that is motivated and capable of exploiting a vulnerability in the system by launching attacks. Correct. Um, okay. Threat. Okay. An attack, an intentional act by which an entity attempts to evade security services and violate the security policy of a system. Okay. So an attack is an active. It's basically an action. Attack is an action. A threat is not yet an attack. A threat is someone who can attack. Right? So a particular threat exists, but a threat could always manifest in the form of an attack. Okay. So passive versus active attack. So as I just gave you a fleeting glimpse of what active and passive attacks mean. So passive attacks, what do they mean is they attempt to learn or make use of information from a system, but does not affect, actively modify, manipulate anything in that system. You only listen, you only sniff the traffic. You don't you don't add anything new to the traffic, right? You don't do anything of that sort. And and active attack is where we saw, right, Trudy, they could basically stop messages from flowing A to B, and you can insert some stuff, some extra malicious messages also in between Alice and Bob. And the fundamental difference is passive attacks, the victims don't know an attack is happening. It is very difficult to detect, right? In active attack, you know something is going on wrong because the attacker is actively interacting with you, correct, and trying to mislead you, right? These are all some other uh, definitions, you can say. So you have attackers, you have different types of attackers, you have individuals, you have outsiders, you have insiders, you have trusted, privileged users. There are more insiders, to be honest. I mean, so this is with respect to an organization. Yeah, we could definitely. I think after the class ends, right? Okay. Okay. I think threat model is. I think let's move on to the next part of the course. I think threat model. I'll introduce it to you when we come to that particular aspect of the class. Okay.
So Harish, what is the difference between threat modeling and threat intelligence? Is this the same or what is it?
Um, Threat intelligence.
So if you have heard about threat intelligence, is the new control added in ISO 27001 2022, which is one of the 11 new control that has been added there.
No, I'm not aware of threat intelligence as it is. I'll have to look into it and get back to you on that.
No
Uh,
issues. No.
Threat model is something that I'm aware of because we work closely with threat models in our research. But
Yeah, yeah.
threat, just give me a few moments. Let me see if I can pick it up from the internet.
No problem. Threat model will help me actually if you just can elaborate. If you're doing the same, that is fine.
Yeah, sure, sure. I'll elaborate it then.
Thank you.
But yeah, threat intelligence is I've heard of it, but since I never had the need to study threat intelligence, um, just give me two minutes. Let me just read about threat intelligence and see if I can pick it up fast. Okay. Okay, I see the difference. I think this is a very. So I've just taken this definition from the internet. It's a very broad term, threat intelligence, I think. So, but threat model is not like that. Let me just explain threat model then as
Okay.
well. So, threat intelligence is when you stay ahead of the curve, where um, you, I think, keep constant tabs of where the attacker is, or what the attacker's capabilities are, so that you can be more prepared. That's what it is about. But I should always look into it further and then comment about it. But I think that's what I understand from this. But coming back to threat model, right? So, how do I explain this? This is slightly going into details of things, but okay. So, what is the threat model exactly? Essentially, let us consider a scenario. Okay. Let's consider a scenario where you have yourself, then this is your laptop, and you have another. Your friend is in the other room. Okay, this is in one room, and your friend is in the other room. Okay, and then you are connected to each other using a LAN cable. What? It's not? Oh, okay. Yeah, I think now it should be. I was just explaining to understand threat model. I was explaining threat model with respect to a scenario, right? So this is you and this is your friend, but you are connected to each other with the help of a LAN, which is local area network, which is basically wired access. Let's say wired, correct? So now, if you look at the threat model here, correct? Threat model. This scenario contains threats that are associated with attacks that could happen on a local area network, correct? In a way, you are modeling the possible threats that could happen in this scenario. So on the LAN network, on the local area network, you can you can do attacks like ARP spoofing, ARP spoofing, etc., etc. So when you're talking about a particular threat model or a particular scenario, then what are so okay? Let me just put it like this. Okay, keep the scenario in mind. Strike everything I just said. Keep this scenario in mind where you and your friend are connected by a local area network. And now, if you want to analyze the the threats in this scenario, correct? What are all the things that could happen? An attacker could be here, an attacker could be here, an attacker could be here, and if he is here, what are all the privileges that an attacker has? Can the attacker send packets? Can the attacker craft packets? Right? So a threat model basically defines the capabilities of an attacker. Okay, what all can the attacker do? And the threat model also defines the underlying scenario or the underlying network scenario or the underlying infrastructure, you can say. So essentially, given given that it is a LAN network, okay, look at this. Given that it's a LAN network, and given that the attacker can do A, B, and C. When I say A, B, and C, he can compromise this laptop, or he can compromise the wire, or he can compromise this laptop on the other side. What are all the attacks that are possible? So we have modeled the threat environment according to these privileges of the attacker privileges, right? So now, is this different for different scenarios? Yes. Now imagine the same scenario, okay? Same scenario, but using Wi-Fi, using wireless. Two nodes are connected. The threat model changes. The kind of attacker privileges change, right? The type of attacks also change. So when we discuss or when we want to talk about the security of a particular scenario, or you want to discuss security, you should always bring it in the form of a model. You should always model it, correct? And define what are the roles of the attacker, what are all the things that the attacker can do, what are all the things that he cannot do. And under these conditions, I am analyzing the security, correct? I'm assuming the attacker can compromise my system over here. But someone else might bring a threat model where he can say, I'm making sure that this part is secure. The sense attacker cannot be here. In that case, what all can the attacker do? So the threat model fundamentally changes how you look at security of a particular scenario. So the same scenario, if I say the attacker cannot be here, then the attacks change. Then the kind of defenses also change. Correct. So that is the practical way of looking at what threat model is. Now, if we look at um, the sorry, the text here, they don't argue about attacks or defenses without understanding the threat model. So it basically defines the problem to be solved. It is looking at things. No, it's not exactly looking at things from the mind of an attacker. So it's slightly more nuanced than that. Um, so it's coming to a consensus, or you can say it's coming and saying, okay, these are the conditions. What are the network conditions? There is A, there is B, there is C. What can A do? What can B do? What can C do? Under this condition, what are all the possible attacks, or what are all the possible threats that we could have? So you're defining a scenario like this. So essentially, in security research, in pretty much every security paper, the threat model is a very important factor, because one attack might work in a particular threat model. It won't work in another threat model. For example, there are certain attacks like ARP spoofing, or not ARP spoofing. Yeah, I think ARP spoofing. You have MAC tables, right? You have bridges in between. So ARP spoofing might not always work in the wireless scenario, correct? So an attack that works in one thread model might not work in the other thread model. So it's modeling the scenario in a way where you can define that this attack can happen here, and then you propose a solution for it. So most network uh, most security papers, I mean every security paper defines the threat model, and then they say my attack works in this threat model. Now I'm going to solve that attack in this threat model. And the question is the threat model practical? So you can always say, you can create your own threat model in your mind, saying an attacker can go here, go there, do whatever he wants, and then now I'm going to solve it. Correct? You can make it more difficult for yourself. You can make it more easier for yourself. It's always in your mind. So the way you look at a scenario, the way you model how the attacks can happen in that scenario. So that is basically threat model. You're modeling the threat in that scenario. I don't know if this was too much, but essentially this is how threat model is. And in contrast to this, um, it's, I think, yeah, the reason why I skipped over this is because it's not exactly loopholes to be patched. Um, okay, you okay, you can say, yeah, you can say, yeah, you have certain loopholes in this threat model, and I want to patch these loopholes. Yeah, in a way you can say that, but that loopholes will be applicable only to the threat model that you created. The threat model may not be practical also, you don't know. You can just say, this computer is vulnerable to certain attacks, so I'm assuming the attacker can be here. I'm assuming the attacker can be here. Whether he can be there or not, we don't know, right? So the general rule of thumb is to create threat models that are as close as possible um, to the real world environment and scenarios, right? So that is threat model. And then contrast cyber threat uh, intelligence, right? So it is not really threat model. I've not read the recent ISOs because I don't work in that area specifically. But so this CTI, it helps organizations stay informed about new threats that can protect themselves. So it's more about having a, to say, being updated, being on top of the threat actors in the world. That's how it is. Bug fixing exercise. Hmm. Bug fixing exercise. Okay, so you can say bug fixing exercise means, like, I think you're talking about okay, bugs and code. Um, See, it's not directly related, I think, at least in my opinion, because bug fixing is a, see, okay, basically bugs are things that happen unintentionally in code that you write. So we are being more specific there. See, threat model is something that models the kind of bugs that you have, right? You have some bugs in your code, and you model it as a part of the threat model. You say my code has A, B, and C vulnerabilities, and then you give defenses and solutions for how do you stop those vulnerabilities. So in a way, I think yes and no is the answer to this question. But I've not heard of anything directly related to bug fixing exercise being spoken in terms of threat model. So yeah, I think the answer is no. But you can always mod the definitions to fit one thing in the other. So again, I, I'm still dubious on the answer to this. Either yes or no, I think. Okay, I think we've spoken too much about theory. Yeah, plus boundary, blah, blah, blah. Okay, fine. So let's look at some practical aspects of it. Okay. Okay. Yes, Ritu, you have a question? Right. So we've been talking a lot about bugs. I mean, vulnerabilities. Sorry, not bugs. Vulnerabilities, threats, um, exploits, attacks. Right. So let's see how you can model one in your own computer and your own system. Okay. Just, okay. So what I've done here is I have opened up something called a virtual machine. So I'm not sure if everybody here is aware of what virtual machines mean. Okay. But it's basically a computer inside a computer. See, I have one system, main system. I have my own desktop. I have all those things. But right, so I have my own computer system, right? And then now I can also run another computer inside the computer. So that's called the virtual machine, virtually using another computer, the system in another system. So let's open up um, another computer inside the computer. This is an operating system called Kali. Have you heard of Kali? You might have, might not have. So you run this system like this. Yeah, it's a distribution of Linux. Probably we won't have time to execute any attacks today. We'll do that over the period of the next few months. I mean, few months, right? Yeah. Hi, Varsha. Is this your first class? It can be accessed. Don't worry, it can be. So what I've done here is I have opened up another computer inside a computer, right? Can you see a desktop here? You can create a new folder like this. You can say, and then you can go inside. You can create another text file here. It's just like another computer, but this is inside my system, correct? It's completely inside my own system. Oh God, okay. So what this Kali machine does is it's got a set of software that can basically be used to exploit vulnerabilities. Okay, so if you find a machine that is vulnerable to certain exploits, then you have tools here that can exploit it. So what are these tools? These tools are created by security researchers or attackers who know that a particular vulnerability works like this. So instead of asking me or anybody else who wants to exploit it to write the code from scratch, they've already written the code and they've kept it. All you have to do is take it and use it. Right. Okay. Now that this is a machine that I have, and of course I have a browser also here. And in this browser, uh, what do you mean offline online? Offline online in the sense, it can be anything. See, what do you mean offline online? So when you say offline and online, it is in the context of which machine you want to attack, right? If the machine that you want to attack is sitting at some remote location, then of course you have to be online, correct? But in this scenario, I'm looking at an offline attack scenario, basically, in the sense I'm attacking another machine in my own system. So like I told you, there is Kali machine that is running, right? And then you also have, I want to start one more server. Okay, so while Kali is running, I want to start one more server here. This is called metasploitable. There's also another computer, but without a graphical user interface. So what is the GUI? So this is a graphical user interface where you have a mouse, you have folders that are visible on the screen. So you have all these things, correct? But this metasploitable does not have any of those. So it's okay. Yeah, you need to learn some Linux commands to navigate. We'll look at that and tell you what those things are. Yes, of course. See, most of us must be very familiar with Windows, where you use just your mouse and your keyboard and you get your job done, right? But when it comes to operating systems which don't have a GUI, a graphical user interface, you need to know Linux commands. Well, we'll just talk about some basic Linux commands. Okay. Okay. So can you see right now? So this is my computer. Okay, this is mine, host system, you can say, and this is Kali. Okay, and this is Metasploitable. Correct. So this is running. This is also running, and where are both of these running? They are running inside my host operating system. So both of these are called as virtual machines. Okay. So this is the architecture right now. And now the question is, host is running here and Kali is running here. Metasploitable is running here. Can Kali communicate with Metasploitable? How do you know? How do you check if two computers are connected? How do you find out? Any approaches? This is Kali and this is Metasploitable. Think, how do you check the world of computers if you're able to say hi to someone, right? How do you check if you're able to connect to google.com? How go to CMD and then say ping, right? What does ping do? you basically send some messages and then you get a response from them. So we'll do the same thing over here as well, right? For Kali and Metasploitable. But to do that, what do you need? You need an IP address. So how do you find out the IP address of a particular system? Does anybody know?
Yeah, IP config.
Yeah, exactly. But is it IP config for Linux?
Even for Windows, we do get it.
Yeah, for okay, one second. I don't know who's speaking. So it's Shobit, right? Shobit was speaking, or
Yeah,
who's speaking?
yeah, I
Shobit.
am.
So IP config works in Windows, right?
Yeah.
So I'll show you. But what is it for? Can you please send the weekly what? What do you mean send the weekly assignment? I don't understand. Um, I think it is sent by the organizers, if I'm not wrong.
Yeah, it is online actually. When you just log in the NPTEL website, so all weekly assignments along with the presentations available there.
And Venkata, if you're not able to access it, you mail the NPTEL help. Okay, so I think it should be unlocked by now. Am I right? It should be available. I'm not sure. Okay. So Shobit was just saying that you use IP config, right? Okay, let us use IP config as he said. IP config. So you're getting all of these things. Right? You have so many numbers, mumbo jumbos over here. So what is my IP address? Yeah, good. IF config. You're right there. So IP config works on Windows where my IPv4 address is 192.168.56.1. That's because I'm on a local area network. This is a private address. I'm not going to go into details of that, but this is basically a unique identifier to your computer. It's a private address. Uh, config, sorry, IP config. It says command not found. We try the same thing on Kali also. IP config command not found. So this is where you're using a different command, but it does the same thing. It's just that they've named it differently. Why they named it differently? Because they want to differentiate between Windows and Linux. That's all. No other reason altogether. That's how it was made. That's how it was built. So no questions asked to be there. Okay. It's if config. So what is the IP address of my system here? Can anybody see the screen and tell me? Of the Kali machines. I'm looking at the IP address of the Kali machine. So what is the IP address here? If anybody has experience in this.
I think IP space A, or I'm not sure.
Yeah, Saira Bhanu is correct. 10.0.2.5. It's INET. I mean, there's nothing because people who are familiar with it, they'll be able to say. So it's 10.0.2.5. So that is the IP address of which machine? The Kali machine. So what is the IP address of this? 10.0.2.5. Correct. Now, can we check the same thing on Metasploitable as well? This is the Metasploitable machine. Okay, this is another separate computer operating system altogether. IF config. So what is the IP address here? If you can see it on the screen, can you? Yes, I think it's visible. So it is, what is the IP address here? It's 10.0.2.4 exactly. So it is 10.0. Oh God, 2.4. Handwriting is terrible. Okay, 10.0.2.4. So this IP address basically is like a postal address for your computer, right? Now the question is, how can I check if I'm able to communicate between Kali and Metasploitable or Metasploitable and Kali? How do I check? I know their address now. I know the IP address of Kali. I know the IP address of exactly. So what will be the ping command? What will be the ping command? Okay, I'll keep the screen open. So I want to check if Kali is able to access Metasploitable. So how will I check? You're right. Ping is the answer. It's a very easy way of checking. So what will be the ping command for that? Okay, let us um, I'll tell you. Ping 10.0.2 dot what? So I need to ping from Kali to Metasploitable. So I'm pinging from 10.0.2.5 to 10. Right. So I need to put 4. So are you able to ping? Yes, you are. How do you know you're able to ping? Because this utility, this ping, sends ICMP messages and it says I'm getting a reply back in 0.528 milliseconds, or rather, the response time is this much. So how do you know if something is not pingable? Just put some random address like this, and then it won't give you any response at all. It says destination host unreachable. So now you know that you're able to ping from Kali to Metasploitable. Right. Now, can we do the same thing from Metasploitable as well? Ping 10.0.2.
5.
4 or 5. So this is just to give you an idea of how you are setting up your own sandbox in your own computer. Okay. Um, now you have a Metasploitable server running, and you have Kali running. Right. Let us try to access Metasploitable server through your browser now. Okay. So on the browser as well, we are used to putting things like google.com, let's say, something like this. Okay. All right. So, but then essentially what happens when you type these domain names, right? It gets converted to an IP address. It basically gets converted to an IP address. The address to a place is not its name, but its IP address. So you have this DNS system that's working that converts domain names into IP addresses. Let's not go into that right now. So what I'm trying to say is you can always put the IP address of the destination system if you know it. So now the destination address is 10.0.2.4. So now can you see this information is coming from where? It's coming from here. This Metasploitable 2 is running a server which is serving this web page to you. Right? Now there are multiple um, applications in this, and these applications are by design made vulnerable. They're by design made vulnerable so that it can be exploited to learn attacks. How do attackers perpetrate attacks? So if you click on one of these, let's say this is an application that says it's born to be hacked. Okay. Now we're almost nearing the end of it. I'll just leave you the teaser right now. So this is a username, login, and sign up page. Now I know that this login, username, and sign up page, this is username, password page, this is login page is vulnerable. I know because that's how Metasploitable 2 has created the application. Now my objective is to type in something here and make sure that I am able to log in. Correct? I should be able to log in without using the correct username or correct password. What are the approaches that you'll use here? Any approaches that you know of that you can use here? or you've heard of. Basically, you need to break into this page. How do you do that? Okay, and then test. Nope, that didn't work out, Ajinkya. Admin and then password as test. Okay, so we're being specific right now. So essentially, you need to inject some code into it such that the server sitting behind will tell you how to bypass this. All right. Okay. So we look at this. We look at how people do this from time to time after we finish the main agenda of the course. Right. The course main agenda is not this. This is just supplementary. Um, so I'll tell you what are the approaches here. So basically, what we're going to learn here is something called SQL injection. So you inject SQL queries and make it execute in malicious ways in the backend. Or in other words, we have a lot of things to learn before we go into this. I also have to tell you Linux commands and how Linux commands are used. And I should show you the application in the middle part of the video. It's going to take some time, so let's not go into it today or right now. So this is just to tell you that by the end of this course, we'll figure out how to, let's say, hack into this vulnerable application. Okay. Now there is a very less time, so I'll just give you the answers to the questions. You can always go back to the weekly videos and find the answers. They are very straightforward, which is why I didn't find it worth discussing. Right? Okay. Right. So yeah. So I'm going to stop sharing. So we'll continue that thread, the second thread, which is the practical thread, in the coming classes, maybe in the future. Okay. Uh, no, no, absolutely not. Absolutely not. Were you there for the initial part of this course? This is why I was very careful when I told you what I'm what I'm gonna what I'm teaching you today or what I'm introducing you to these exercises, right? They're not going to be a part of your final exam at all. Please follow only the main videos that the professor teaches. That is what you're going to get for the exam. This is just because people asked for some practical introduction to network security or pen testing or cybersecurity as it is. And that is why I'm showing you this. Please do not quote this. Please do not think this is what is going to be asked in the exam, because the course talks about organizational security. That is very theoretical, and that's a different flavor of cybersecurity, right? So this is not going to be asked for a final exam at all. Not at all. Okay. I think it's MCQ if I'm not wrong. I'm not sure. Again, ask previous people or someone who has already taken NPTEL exams. If anybody is here, please try and answer. Um,
Yeah, so as told by Sajike Matthew, he told me in final examination, it is all objective because it is online. So questions may be, one of the four alternate available or could be MCQ. But definitely it's not
meaning,
subjective.
oh, it's not subjective. Okay, so that's the answer for you, Pratiksha. It's not subjective. Okay. Um, yeah, that's the IP address, Venkat. Okay. So, okay. So I'll just quickly breeze through the answers for this.
बोले तो
Right. Somebody was telling the answer to this question. The answer is C. Correct. The answer is C. It's information security framework. Next is this true or false? So if it's true or false, it's a guide for developing security plans is considered the foundation of a comprehensive security blueprint and framework. Mm, So the answer is true. Right? So it is the foundation. That's where things started, I think. Yeah. So this layered approach to security, right? What is it called as? It is called defense in depth, right? It's D. So by the way, this is being recorded, so you can always come back to these questions and answers. But and I think these questions will be discussed more in detail by the other two PMRFs as well tomorrow. Not so you can attend those if you find this inadequate amount of explanation. So this is no, but as per the official guide, the answer is C. ISA, CA, and IT governance is what the answer to this question is. Right? Yeah, correct. Okay. Now, since the screen is there, you can always take a look at it. Now we're running out of time, which is 32 already. Okay. Three approaches. This is very simple. So what is this? Three. And the answer is C. Standard-driven approach. Correct. And question 6. This particular uh, version involves guidelines for what? This involves guideline for network. Sorry. This is not network security. This involves guidelines for cybersecurity as a whole. It's not specifically network security. Network security is a part of cybersecurity. So the answer is B. Okay, so the 5 goals of information security governance are, I hope you're able to see the screen. I'll just match the answers. So the answer to this is E, right? What is E? Value delivery. And so to 2 is C, and answer to 3 is A, and answer to 4 is B, and answer to 5 is D. This is directly theory, so I think this is not probably tomorrow. After tomorrow, the other PMRs will discuss these questions in more detail. Okay, and what is the matching here? The
A.
answer is either A or C. Just give me a moment. A.
The hint is option D, 27,005, 7,005 is risk management. So in all alternates available, D is 4 in option A only.
So yeah, you're right. Option A. So A is 1. B is 2. C is 3. D is 4. E is 5. So such configurations also exist. Okay. So last question, what is it? The answer is A. So it is ISG and CIO and CISO. You can always find more details about this on the video, right? So I have to run now, guys. And Ajinkya, regarding your WhatsApp scenario, we can probably discuss it at a later point of time.
What
Have
is
to walk
ISG,
up.
sir? What is ISG?
Just give me a moment.
ಎಷ್ಟೊತ್ತು
Well, actually, I think I'll have to get back to you on that one. So I have not specifically prepared for um, these questions. Probably, I think it's better if you attend tomorrow and after tomorrow's session for this question number 9. You can ask him the question. I'll probably get back to you with the answers. I'm just reading out the answers from the official guide. That's all. Yeah, sorry for that. I'll get back to you with the answer in the next session. Okay. Is that fine? If anybody else knows the answer, so let it know.
It is
Today, the
information.
security guideline.
It is information service group.
group.
Okay, information service group. Okay, and CIO is Chief Information Officer, and CISO is Chief Information Security Officer. Right. This thing I think everybody knows. So what was ISG?
Yeah, that is information security group.
Okay,
Information service group.
service group. Okay.
Yes.
Information services group.
Okay, services group.
So
Okay.
I have one question, like how often as a cyber security personnel or a like executive in an organization, how much do we need hand-on experience with these practical part? Because this course is totally driven for the management part. So
Right.
so how much hand-on experience do we require with these all tools, like exploiting the vulnerabilities or DDSOs, or because again when it comes to the satisfying the standard or frameworks which are there in the at an international level, we need to drive out with those reports and your extract of those result is the result. So how do we explore it, or how much do we need to have an end-on experience?
Uh, so, but fundamentally, I'm a applied security person. So, so when it comes to this course, right, this is a management course which talks about security, management of security. So how much is hands-on required for this question? So once again, that goes on to your goals of what you want to do. You want to be a policymaker? Do you want to be a security policymaker, or you want to be a manager? You want to manage a security team, as it is. So I think it's always goal dependent in this case. I think that's where that's what I'd say. Will always add more value to your own understanding if you know how these things work, how these attacks work, and there are more nuance. If you have a more nuanced understanding of how these attacks happen, it'll always help you uh, create better, more robust policies, right? But in
But when we say in information security, when I talk of 27,000, we have to prepare certain certain things like BCP plans, risk identification plans, or these identified vulnerabilities, and one more thing was that all these documents are required for an organization to qualify the certifications and those practices, the best practices which are there in the industry. But those outputs are coming from these inputs only. So as a person who is working in the IT domain, how he or she should be like, how much experience do we require on these part, कि हम किसी भी, if we are going to any project and then we are checking on how the things are moving in those projects, and are they in place or not, or there are any vulnerabilities or any condition where the project is not satisfying according to the client. Because then how much experience do we require? My point is that
Experience in terms of hands-on.
experience in terms of, like, if I say I have a project where I have a client data, which is again project requirement data, then my code, then my configurations, version controlling of those like codes or the deliveries, then my agreements which are signed by the client. So these are certain things. But again, how do I confirm and check that whether my developer has not like coded something which is not allowable? Like if I go to certain case studies, there was a case study long time back where a person has put in a code ki if there is a bank transaction and whatever amount that comes in a paisa, that has to be transit into the person's account, and the person leaves an organization and he was working on a banking project, and one fine day there was a check and some person find out ki how many transactions are going like this, and all the transactions were of in paisas, but it is coming to a big amount. And then a reverse engineering was happened, and they found that the person was there in the same banking project, and he had put in a certain piece of code where he has given a transaction ID as in to that amount to this much paisa. So how do we assure that these things are not happening, and these kind of vulnerabilities or this kind of chances are not there in any of the project? Because as we are going towards the this 21st century, many of the things are coming into GCRs and risk assessments and cyber security, these kind of things. So Esa, how do we assess all these things as an information security personnel?
Right. So what the scenario that I just explained was basically a backdoor created by a disgruntled employee, right? So he was trying to siphon off the paisas into a particular amount. So, but the question is, as a team leader or someone who is managing a team, how do you ensure policy compliance? That's what it comes down to, right? Your question. How do you ensure the policy is complied in whatever
Right.
the it's possible, it's policy compliance basically. So see, you have, I think, see, I don't have much experience in this area, but I can always speculate. So you have many automated tools that are available that check policy compliance first, and now you also will have AI based tools that enter into this domain, which can probably plug vulnerabilities like the ones we just spoke about, right? So the input to these tools will be your policies in a language that the tool understands, and the output would be that the tool is going to look at all of your code base and the interaction between different modules, and then check if the module interactions are compliant with the policies that you inputted, right? So there are multiple modeling languages for this. So that is one automated way of checking the compliance with policies. But and by the way, how do we ensure? You literally can't. It's just because you can't ensure is why you're having so many vulnerabilities, right? That's the problem of the world right now. So if you can come up with a way to ensure this, then yes, you are. That's a valid contribution. You'll be famous. How do we ensure this? It's still an evolving. It's still an evolving. Um, what do you call area, right? You don't know. Nothing is for sure. So if you can ensure that, then that means you've broken through. I mean, you've done breakthrough work, right? So in the end, it also comes down to the way your employees code. Then sometimes code reviews don't happen. They don't happen the way it's supposed to. So most of the things can be caught during code reviews before an employee pushes their code or merges or creates a pull request and merges their code onto the main code base. If you can catch it then and there, then it's all problem solved. But most organizations don't just do pull requests at namesake, right? So certain things can be tightened these aspects, and maybe things could be better. But yeah, it's still an open question.
Okay. Thank you.
Yeah, I think we'll end today's session. Okay, thank you.
Thank you.
Thank you.